monitoring, variable module registration, sensing, supervision, collection of information on the behavior of these parameters, data sample, evaluation or analysis information, and historical behavior. The diagnosis, determination of failure type and its root cause. Application of corrective actions. Alternatives. Smart decisions. Intelligent and autonomous system. Solution optimization techniques. Smart system, neural networks and fuzzy logic. Action. Maintenance, predictive, proactive, replacement. Construct the Hessian tree for problem identification in any of the machine tool. Hessian tree for problem in machine tool. Milling. Strategy for measurement and analysis. Machine classification. Construct the Hessian tree for fault tracing in pump. Hessian tree for fault in pump. A pump coupled with an electric motor is one of the most significant pieces of equipment within any industrial setting and is considered a high priority asset for failure analysis. Similar to an FMEA on pumps, FTA would also require the realization of interconnected subsystems that constitute a pump assembly. For example, any standard centrifugal pump would require the pump compeller, seal, suction and discharge nozzles, bearings, etc. Similarly, a coupled electric motor and its associated instrumentation and controls are also part of the pump motor assembly and can trigger pump failure. Any single or combination of failures within each of these components can impact the pump operation and therefore they need to be considered in the analysis. Due to a larger number of components with various interdependencies, the pump FTA can become fairly complicated if the team is missing credible failure data or lacks experience on how to interpret fault trees correctly. The steering point to construct the fault tree for the pump would always be defined on top failure event and branch out further events that cause the top event. The top event can be as simple as pump failing to operate, centrifugal pump with sensor data acquisition and signal conditioning, feature extraction, feature selection, testing data set, training data set. No. Is model trained? Yes. Trained model output pump diagnosis result. Construct the decision tree for fault tracing in air compressor. Decision tree for fault in air compressor fault diagnosis, vibration signals using accelerometer, data acquisition and signal conditioning, statistical histogram and ARMA, feature extraction, feature selection using decision tree to training data, testing data. No. Is decision tree model trained? Yes. Train decision tree model. Lazy K-star, decorate and RBF network classifier, multi-fault conditional classification. Considering the fact that compressors work at high cycles, generated vibrations and fatigues are factors contributing to fracture and failure of these sets. In normal operating condition, compressor has an allowed range of vibrations. If these vibrations exceed a defined limit, it suggests that compressor is no longer operating in normal conditions. On the other hand, each part or element of compressor runs at a certain frequency. If a failure occurs in this set, it is represented at a distinct frequency and range of vibrations. Therefore, the present study uses vibration signals for condition monitoring of compressors before analysis of signals. In pre-processing steps, samples were imported into MATLAB software and wavelet waveform of each sample, which represent distinctive states of compressor, was done. Signals collected by sensors in the first step were wholly at time domain. Although vibration data offers valuable information on condition of the machine, such data does not include failure signal, and there are numerous noises in them. The noises in time domain signals problematize direct detection of failures. Draw the decision tree for fault tracing in internal combustion engine. Decision tree for fault in an IC engine. 4-stroke IC engine under real-time running condition. Attached eddy current dynamometer in dynamometer 2 engine. Attached eddy current dynamometer 2 engine and mount accelerometer on gearbox to control and loading the engine and vibration measurement. Hood gearbox, new defect free gear, defective gearbox, progressive gear, toolkit defect, data acquisition, vibration signals, collection of good gear as well as defective gear, effective gear, feature extraction, discrete wavelet feature extraction, feature selection using decision tree approach, 148 algorithm, training data, testing data, and his algorithm trained by training classifiers output, gearbox fault classification, about flaws for classification. Construct the decision tree to identify fault in a boiler and electric motor. Decision tree for fault in a boiler. Restart procedure: cautious restart, aggressive restart, stream distribution ratio, campus SUH 85% 15%, stream distribution ratio campus SUH 50% to 50%, stream distribution ratio campus UH 85% to 15%, steam distribution ratio campus into UH 50% 50%, no leakage on steam system, leakage on steam system reducing steam delivery by 50%, no leakage on steam system, low leakage on steam system reducing steam delivery by 50%, no leakage on steam system, leakage on steam system reducing steam delivery by 50%, no leakage on steam system. Issue 3 for fault in a motor. Motor overheats. Primary motor failure. Overheated one. Excessive current to motor G2 and excessive current in motor G3 or primary failure. Fuse fails to open to primary wiring failure. Shorten 3. Primary power supply search for list out the types of fault associated with machine tools. Types of machine tool faults. Machine tools in the process of use, there are often some faults such as not timely elimination will directly affect the production, will make the precision of the machine tool rapidly decline. Therefore, it is very important to summarize and analyze the fault causes of machine tools and explore the methods of troubleshooting. Generally speaking, there are the following causes of failure: the machine itself, of the mechanical parts, electrical components, hydraulic equipment, and other work failure, or some parts were badly accurately is out of tolerance, and even damage. The machine tool is inaccurately installed, improper daily maintenance, unreasonable usage. The original design of the machine tool is imperfect or unreasonable.